Hello everyone, I am Oshu Solanki, final year student. I am going to present final year project work for dynamic response of steel frame with the different bracing system subjected to the earthquake sequences. This work I have done under the guide Dr. Vasudeo Chaudhari. So let's start. First of all, table of content, introduction, literature review, rest time, methodology, selection of model for a study, numerical model, validation of model, selection of ground motion data, map the target spectra, result and discussion. Last one is the conclusion. General introduction. The recent case of Turkey has used main shock and then number of aftershock are coming and more damage for the structure and collapse of the structure. In this video you can see the damage for aftershock. This building are collapsed in aftershock. The building this part also damaged for the aftershock. This part. People have done the research on the aftershock but not steel frame with the different bracing system. That's why I have done this project. The bracing system play a crucial role initially stability and the safety of the structure such as bridge, industrial buildings and the transmission tower. The most of the code priorities only safety for a main shock event, but the potential damage for the aftershock must also be considered. The scope. Develop a numerical model of a 12-story frame with the various bracing system using OpenSys software. Performs the non-linear dynamic analysis of frame from the main shock and aftershock sequence. Third one is a compare of the performance of different bracing system near field and far field ground motion data. Validation of model, selecting the ground motion. This one is foreshock, main shock and aftershock. The main shock before the small earthquake is called foreshocks, and after the earthquake is aftershock. Aim to evaluate the performance of steel frame with the different height and bracing subjected to the earthquake throughout the numerical study. Objectives. First one is the selection of the structure, geometric calculations, selection of material. Second one is the literature review. Third one is the selection of ground motion and match the target spectra. Fourth one is the development of the model in OpenSys. Fifth is performance in dynamic analysis, and sixth one is the result. Literature review. First of all, author, article, general and main finding. Chuzi Shubai, the article name is the earthquake energy, earthquake volume, aftershock area and the strength of the earth crust. The journal is the physicals of the earth. The main finding is the aftershock area expand with the main earthquake magnitude, while the earthquake correlations in the Japan decrease with the distance. The magnitude energy formula E is equal to 6 into 102 into A 1.5, combining the earthquake size and the aftershock areas. Second one is same thing is article is a state dependent fragility curve using a real and artificial earthquake sequences. Journal is a civil engineering. Omri's law formula and count T is equal to K bracket T plus C count close minus 1 is using to derive the fragility curve for a 4-story frame. A fragility curve based on Omri's law, where the objected using a 25 ground motion record. Third paper is the seismic fragility assessment of a self-centric hybrid precast wall subjected to the main shock aftershock sequences. His general is a civil engineer. A 5-story case study structure utilized the SC and the RC walls to resist the lateral seismic forces, the main shock damage, and the collapse capacity of the both walls are reduced in the attainment. Fourth one is the seismic fragility analysis of nuclear power plant structure under the far field ground motions. Civil engineer student general. The study utilized the 11 earthquake sequences and the found that the executive buildings sustained less damage than the slide buildings, effectively evaluating the fragility for the risk assessment of the damage requirement. Fifth one is the fragility analysis of the reticulate domain subjected to multiple earthquakes. Is the main finding is Young's and Jones papers examined the single layers and the double layers reticulous domain with the 11 earthquake sequences. Aftershock significant impact fragility analysis with the tire occurring the increase at higher damage levels, leading to the incredible collapse probability. Sixth one is the empirical fragility curves for the non-residential building for the contributing earthquake sequence. His general is also a civil engineer. Slide link papers compare the non-residential building in the New Zealand and the US using earthquake sequences for the SEBA. The study find that the unreinforced masonry buildings are the more vulnerable, while the New Zealand non-residential timber structures are strong than US residential structures are. In this type of study, one of the crucial parameter is the rest time. The people have considered the different approach to consider the different rest time. Uh, main shock, main shock and aftershock between provide a gap because of the structure has a stable, and then immediately aftershock has a real. This formula has used R is equal to TD bracket 21.8559T plus 0.0258 bracket close bracket TD bracket minus 0.9982 plus 0.0214 bracket close. R is equal to minimum required rest time. TD is a strong motion duration. T is equal to vibrational period. Required time between main shock and aftershock for dynamic analysis for structure. Rest time research paper. First of all, author, article, and rest time. The required time gap between the main shock and aftershock for a dynamic analysis for structure using a 40 second for a 12-story building. Effective of the seismic sequences in the reinforced concrete frame building located in the soft soil using a 40 second. Study of the dynamic behavior of the isolated AP 1000 NIB under the main shock and aftershock sequence. Basically is a nuclear power plant using a 10 second. Risk based of main shock and aftershock performance association of the SMA braced steel frame using a 10 second. Damage demand assessment of the main shock damage concrete gravity dam using a 20 second. Selection of model for a study. The study simulated a 12-story frame using a OpenSys software. The cross-sectional area was 21.95 meters into 21 meters, and the frames were the model using a two-dimensional element with 3 degrees of freedom. The frames were the construct using a steel two materials with the I-sectional beam and columns as a structural elements. This is the plan. This is the elevation of 12-story building. Uh, Type of bracing system. The different bracing system were used in the simulations to evaluate their impact on the seismic performance of the building. Throughout the analysis of the seismic effect was considered to determine the effectiveness of the each bracing system in the resisting the earthquake load. Inverted V bracing, K inverted K bracings are used. Steel frame damage. In the FEMA 273, three type of damage for seismic events. Immediately occupancy, life safety, and third one is a collapse. You can easily see this table. uh, Moment frame, for collapse purpose, 5% transitional and permanent. Life safety 2.5 transitional, 1% is permanent, and third one immediately occupancy 0.7 transitional and negligible permanent. Same things are basic braced steel frame, 2% of transitional permanent. Lap safety is 1.5 transitional and 0.5 for permanent. Immediately occupancy is 0.5 transitional and negligible permanent. Numerical model. First of all, generate the elements. Second is the assign the materials properties and the sections. Third one is the apply the boundary conditions. Fourth one is the finding the mass, and fifth one is the define the load, and last is the analysis in the OpenSys. Validation of model. This is the actual mode calculation, and this is the expected mode calculation. This one is a reference to this paper using reference purpose. These are the frame. V inverted V, K, and inverted K is the first mode. Time period is the 9.9244 second, 9.91254 second, 8.54755 seconds, and 10.7722 seconds is the first mode. This one is second mode. This one is the third mode. This is the actual result, and this one is the expected. Is almost same, but some difference are also seen. Because of the different mass have assigned, that's the reasons time period are different. The mode calculation for a V bracing system. Um, First mode, second mode, and third mode response. You can see the parameters of mode share. Period, model participation mass ratio, cumulative model participation on mass ratio. First, this one is first mode, second mode, third, fourth, and fifth mode. The time period different. This model participation mass ratio is easily see 80.8711. Second one is a 10.4398. Third one is a 3.87652, and this one is a cumulative. This one and this one is plus, and you can see easily 8.8711 plus 10 is a 91.3109 plus. Main thing is mode 1, 2 and 3 are a crucial role in the any simulations. This one is a inverted V. Same things, mode 1, mode 2 and mode 3. You can see the difference for mode 1 and 2, 2 and 3. This is a reaction of structure. These are the same thing as the mode, period, multiplication ratio, cumulative, K-bracing system. Same thing, mode 1, mode 2 and mode 3. These are the parameters. Fourth one is inverted K-bracing system. Mode 1, mode 2 and mode 3 reactions. There is a time period, mode of participation, mass ratio, cumulative mass ratio. These are the percentage. Same thing. Selection of ground motion data. This ground motion data collect for a peer software. First one is RSN number, earthquake name, station name, year and earthquake magnitude. So RNS number is 1193, Chichi, Taiwan. Station is CHYO24, year 1999. Earthquake magnitude is 7.62. Main shock and aftershock is 5.9. That types of almost 16 ground motion data I was collect, and 8 ground motion is near field and 8 ground motion data is far field. Met the target spectra. Met the target spectra from the Seismometz software. First of all, selected the ground motion data, and then define the target spectra. Structural code IS 1893. Part 1, elastic spectrum, damping ratio 5%, seismic zone is 5, soil type is C, and match the target spectra. This is the original target spectra. This is the ground motion data target spectra, and then match the target spectra. Parameter for the accelerogram spectrum, and this one is the unit of the parameters ground motion data. This is a parameter, is the original data, and this is the mesh data. First is the main shock and then aftershock. Is the time history. The match the spectra, minimum time is 0.02 second to 4 second. Result. This one is the story, and this is the percentage drift for a 12-story buildings with V bracing system with the near field ground motion data. This one straight line is show the main shock and aftershock, and dotted line is main shock effect for a V bracing system. This is the 8 ground motion data for a near field, and this data to average. This one is a main shock and aftershock average, and this one is the main shock average for a near field ground motion data. Same thing done by far field ground motion data. This one is the story, this is the percentage drift, is the same thing. This line is the main shock and aftershock, and dotted line is the main shock. This is also 8 ground motion data used, and this one is the average for main shock. You can easily see this graph, and this one is a main shock and aftershock, or main shock and aftershock for a far field ground motion data. is a compare with near field of motion and far field of motion data. This one is this one part is a near field of motion data for main shock and aftershock, and this one is far field of motion data for near field and main shock and aftershock. This one used for main shock for near field of motion data, and this one is the far field of motion data with main shock and aftershock. This is the comparison. You can easily see the more damage for a near field of motion data. This is the all bracing system. For bracing system, main shock and aftershock compare. Uh, the first one is the V bracing system, and second, third is inverted BB and K bracing system. You can easily see the V bracing system results are good. Some parameters are crucial role. Conclusion: this research aimed to investigate the seismic response of the 12-story steel frame using for different bracing system K inverted KV and inverted V. There, the primary objective was to comprehend how their system, including the frame capacity to standard earthquake. Moreover, the study conducted comparisons between the near field and far field ground motion. Obtained the results revealed the near motions inflict more several damage to building in the comparison of to far field motion. This underscored the significance of the considering the proximity of the earthquake when the designing the structure. Among the examined braced system, the V bracing system inhabit double the advantage in the demonstrated supreme performance in the specific expected the inclusions in the effectiveness in enhancing the frame seismic resilience. Consequently, architect and the engineering may the comprehend then the conclusions of the V bracing as a dependable approach for the seismic design. These are the reference, and thank you so much for watching this video.